introduce yourself.
Yeah. Erich Knight. I've been a major advocate for 7 odd years now of trying to network everybody who has anything to do with anything about soil carbon, and of course the biggest tool of soil carbon being biochar.
It's very odd years.
Huh?
Very odd years.
So, I just wanted to add to Ron's thing really quick. I have some connections at EPA who tell me they have been mandated to monitor all the geoengineering plans. Now, this person I've been briefing for 6 years on biochar. And also I went to high school with him. So we have an ally at EPA who knows everything about biochar. I forgot my thumb drive. It's in my hotel, but the slides I had were actually my slides from Sonoma last year. So they're just pretty pictures of gardens with flowers growing 20–25% better. So you see plenty of and corn growing better and everything growing better. And I don't even know, well.
Enter your search there.
And I'm a horrible typist. If somebody could come in and type agricultural geoengineering, past, present, and future, which is the title of my talk. Okay, first, in physics, this year there has been a lot of new research, and pyrolytic carbons that come in many forms, not just the form we're concerned about in the soil, biochar, have shown great benefits in all sorts of material science. C60 fullerenes, nanotubes, all the solar thermal electric devices coming out, superconductive devices are all based on nanocarbon, graphenes, fullerenes, and such. In climate science, atmospheric carbon particles, the carboniferous cloud seeding nuclei. A new paper came out from the Advanced Light Source at Berkeley. They have a pulsing laser the next generation of microscope, and they looked into carboniferous cloud forming particles, and they found in the center of every one a potassium seed. All these physicists shook their heads. Where did the potassium come from? And they finally talked to a biologist. And soil fungus, the mechanism to sporulate their seed, their spore, uses a potassium engine. All atmospheric potassium comes from a healthy soil. And that is 80% of every rain cloud. Okay? The panoply of cloud-forming nuclei. You know, there's sulfates from the oceans. There's microbes from trees, but that's a carboniferous one. The stomas of the underneath of leaves release these bacteria. They float up and they form the seed of raindrops. But all these carbon particles, soot, are nano in size. It takes this potassium to agglomerate them to a large enough particle to have condensation form. So life, soil life in particular, calls to the rain. How evolution did this, how soil fungus knows that the trees need water for them to send them the sugars that they live on, is such a confirmation of Gaia. I just wanted to be a fly on the wall when James Lovelock in England read this, and when Jim Hansen at NASA read this, because his 100 gigatons of new forest has a much greater potential than even he assigns to it. So I sent all this to Jim Hansen. He sent me a nice email. Show me what you got, boy. In fact, I asked Jim Hansen to be our keynote speaker. He did not even address my question. It was, show me what you got. So I got Dr. Aminetti and Dr. Wolf and Dr. Molina, who is our Nobel Prize supporter of biochar. He got the Nobel Prize for the ozone hole. And we forged together addenda for Jim Hansen's new paper on how to avoid, the scientific case for how to avoid dangerous climate change. I packaged it all up. I added Alan Savory's Holistic Management with all the support citations that Jim would drink, because Jim doesn't drink anything unless it's solid science. He sent back an email with this addenda, and of course I included some extrapolations. And I knew he wouldn't use my extrapolations, but I wanted to show him the potential. So I added, first of all, the non-extrapolated billion-ton study of biomass that came out a couple years ago, and there was an update, the Sun of a Billion Ton, and that's all from, you know, the Department of Energy and USDA, and it's a very solid document. But then I added some of the work of Arturo Velez. Oh, there I am. How do I scroll it?
Far right bottom.
The arrow
right.
buttons.
Bottom left, up in the bottom left.
There we go. Oops, wrong way. Oh no, that's just who I am. That's not my slides. So back to my interlude with Jim Hansen, which I think is one of the most important parts of this paper. So he sent me back an email. So I also added the work of Arturo Velez, who has proposed for the southwest and northern Mexico agave, which is a type of plant with no irrigation, with no fertilizer, can double the biomass yields of the United States. Right now, the 2012, there was 1.5 billion tons of biomass harvested. Agave alone in the Southwest could do 1.5 billion tons. So by 2030, this is what I'm telling Jim, we can have 3 billion tons of biomass. And now, this is where my extrapolations come in. Thanks to Mike Rocky, I have some solid numbers from his company. And so I said, what if Cool Planet processed all 3 billion tons of biomass? How many reactors would it take? How much gasoline would it make? And where does that fit to our current usage? And it's about over 2/3 of our current gasoline production. 150 billion gallons is what we use now. With 1.5, just our 1.5 billion tons of biomass, we can make 120 billion gallons. And then with 3 billion tons of biomass, we've got plenty of room to spare. So this all says to me it's very positive. The whole reason I got into soil carbon is I was depressed that the American people would never give up their free energy lunch. They would never account for carbon. They had the right to put the pedal to the metal. That's the American way. Well, thanks to Mike Rocky and his guys, Mike Cheeky here, and Mike Rocky's one of his guys, excuse me, we have an answer to the people who are unconcerned about the things we are concerned about. We have, just as I go to the bankers, and I go to the Republicans, and I go to Bob Goodlatte, who used to be chair of the Ag Committee, who is a dyed-in-the-wool Republican. I put on my Republican sheep's clothing. I talk about yields, dividends, premiums, that carbon has a tremendous value in the soil, and we should not let those damn tree huggers own this technology. Because in Australia, the Conservative Party, the Tories, they went up against the Labour Party, who put in a cap and trade system and who built this $5 billion fund to fund renewable energy from the carbon tax and trade. Now, back then, when the Labour was in power, the Conservatives said, hey, we can sequester more carbon with no tax by forestry, by direct action, by paying our farmers to build their soil carbon. And so I tell this to Goodlatte. I tell this to any banker, any conservative farmer. I don't even talk about the atmosphere. I say that carbon is value. All political persuasions agree. Building soil carbon is good. Good for your kids, good for your yields, and you know that, don't you? And I walk out of the room and say, it's value on the table. We have to harvest it. We have to put it to work. Isn't that what Republicans do? You know, I mean, I can get a little carried away. I've also, over the years, worked with Bill Rudiman at UVA, and a lot of you have probably read his work on paleoclimate and how the global warming really started with the agricultural revolution. That 2/3 of the carbon in the atmosphere does not come from oil or coal or any fossil fuel. It comes from 10,000 years of the plow on the soil, of fire management, of burning biomass. We've been burning biomass for 1 million years. 1 million years. The combustion age started 1 million years ago. The latest archaeological evidence in the caves in South Africa show we were cooking food 1 million years ago. We knew how to harness fire for 1 million years. Now we harness carbon in many other ways. We have nanocarbons and, as I say, the nanotechnologies. And we grow carbon into everything imaginable. Human tissue, we can grow carbon into human tissue. We can grow carbon into glass, steel, you name it, we can do it. Fine, okay? So, the unintended consequences of all this liberating soil carbon into our atmosphere, 2/3 of it, the other third in the last 150 years is gone a little overboard. So now we just have to put that carbon back to work, back in the living cycle of life. Biochar is probably the most powerful tool to do it, but there's best management practices, there's holistic grazing, there's rock flowers and remineralization, and all of these working in synergy. And I agree with Ron, Aminetti and Wolf are underestimating by at least 2 gigatons. I think we could do 3 or 4 gigatons rolling off a log. So that's 4 Princeton wedges. And when you add nuclear or renewable energy as wedges, we can get our 10 to 12 wedges. No muss, no fuss. I have a whole section on long-term field trials, but I only have no minutes left. And you can go to any of my blogs and read about blue leaf in Canada, 42 degrees northern latitude, with an average blueberries this year, 40% increase in yields. And the secondary harvest, 60%, squash, 25%. And this is in Canada, where it's cold. Now, in the mid-Atlantic, if you look at most of the long-term work, particularly at Virginia Tech, they're pulling 30, 40% increase in yields. when you go to the southern soils with a very high metabolic rate, they're usually pulling, 40 plus, some 50 and 60. Some in Africa, doing even better. So the other thing I just want to touch on. Do I have 1 minute left?
You got 2 minutes left.
Oh, good. Okay. For ever since the Iowa State conference, where Corneliuson and Ellen Graber from Israel showed up with their heavy metal remediation work, I immediately sent that to the top environmental engineers at DuPont. They ran with it. For the last 2.5 years, they have been remediating methyl species mercury from old rayon legacy plants from old World War II, so my kids can't eat the fish in the Shenandoah River. I could eat them all day long until I die and be okay, but my kids can't, okay? But they took a leaf blower and some cowboy charcoal and put a hopper on it, sprayed it on half a pond on the old rayon plant. The first bioassay, 20% binding. That was in a couple months. 6 months later, 40% binding. As the bioturbation, the worms are turning it under into the deeper sediments, getting down to that methyl, locking it up. You're breaking the first rungs of the food chain ladder. If the microbes can't get to it, it doesn't get to the tardigrades and the nematodes and to the shrimps and to the fish. So they are running with it. They are expanding the pond work. And I said, Richard, well, haven't you published anything? I got a conference. I got to show it off. And he says, well, if DuPont paid me to publish stuff, I would, but they don't. But they are expanding the program to the river, to the fields of the whole campus. And I said, well, Richard, I know this means job security for you, but if you go full scale, how many years do you think until my kids can eat the fish? 9, 10. Pennies on the dollar. There is no technology for remediating mercury. You dig it up, it costs billions of dollars. And all of the stuff, the silt goes downstream. So you can't really clean it. You can't, even if you could contain the sediments and de-water them for another $1 billion and put them in a landfill for another God knows how many billion dollars. But this is in situ. You just spray it on. It settles. The worms take it to where it needs to go. And over time, it binds. It keeps it out of the food chain. And that is the best we're going to do with some of these toxins. Vietnam with 2,4-D. Any place, a brown field has heavy metals. Biochar could be the cheapest solution. Am I done?
Yeah, you got 3 minutes for questions.
Okay.
And I got when you were doing your interpolations around turning biomass into fuel, did you consider increased fuel efficiency standards?
Well, yeah, no, I didn't even calculate that. Going electric, all the efficiencies that are just natural.
So that just bumps the number up even more.
Right, but those are all added. But yes, Mike?
Yeah, so the cool plant thing with fuel, it's a contrarian solution because actually you want to use more fuel, not less. The more fuel you use, the more carbon goes into the soil. Like I say, it's the ultimate contrarian solution. So
Yeah, but when you talk that way, Mike, as I've given you a hard time.
you're crazy. You're
No.
crazy.
No. You get too much blowback from the environmental movement. Especially the world is a closed system thinking movement. And so anytime you go contrary to conservation, you're going to get that. So even though I agree with you, it's absolutely true, the more you drive, the cleaner the atmosphere becomes. That's like, I could make a religious analogy, but you know the type of blowback you get.
Yeah, it's a credibility stressor, and that's one of the biggest things
Right.
we're trying to overcome right now with education.
Right.
And it's no small hill to climb.
Right. But just to give you the absolute numbers, 12,000 of Mike's 10 million gallon per year reactors, just 12,000 of them, building 1,000 a year, which is a real possibility, could get us to that 120 billion gallons of biogasoline by 2030. Okay, and that's where the son of a billion ton biomass study projects the U.S. biomass yield at 1.5 billion tons. And then I also added, just for insurance, the agave marginal plant biomass energy dedicated crops, just for insurance.
Could you take that a step farther and take it down to parts per million and what that would do in reduction?
I'll let Mike's guys do that. I didn't cook those numbers that way.
This is all laid out, and Google hosted a conference called Solve for X over a year ago. And if you go to YouTube and you put in Mike Checky and Solve for X, you'll get his 12-minute Google moonshot talk on how this can be accomplished. And the number, it'll pull down 100 ppm in 30 years.
There you go. And just let me add, you forget that we have at least 200 gigatons in the atmosphere that we need to get into the soil. But as soon as we do that, there's going to be another 200 gigatons that will be liberated from the ocean. So we really have 400 gigatons that we need every molecule into the soil to revitalize the hydrology cycle and to increase this cloud nucleation through increased net primary production. That 100 gigatons of forest of Jim Hansen's has much more potential, like I say, than he even realizes, and that's why I sent him this cloud nucleation paper, because it changes the map. I mean, they still don't know the exact percentages of aerosol particles, you know, the full panoply. There are microbes, there's dust, there's the carboniferous from the plants, and, you know, and all of these species of nucleating particles can be accelerated through soil carbon and increased net primary production. It all feeds into the same.
So the increased primary production, I think we're underestimating that. So
Absolutely.
some of the crop trials we've seen, we're using 30% less water and getting 60% increased biomass growth. We're not taking this into account on what that.
None of that's in the models. You're absolutely
None of it's in
right.
the model, so there's upside here. Usually there's only downside on these calculations. Here I think we've got real potential.
Where
for
we're
some
so
upside.
underestimating the potential.
What is the potential for removing radioactive contaminants like in Japan?
Okay, Super Stone Clean, a company in Japan who's been making pyrolysis reactors for many years now. They first started using their Z machine to process electronic waste. You just throw the cell phones in, throw the computers in, pyrolysis eats all the plastic, and then the magnetic ash comes out, and you can separate all the heavy metals that you want, the ones you want to recycle, and the ones you can't. You vitrify them and throw them in a cake. Well, they're using that machine to process the Fukushima tsunami waste and concentrating the cadmium and doing that. Now, in the salt-spoiled soils all along the coast of Japan from the tsunami that weren't radioactive, they're using the biochar from their regular machine to remediate and bring back the agricultural productivity of these soils that are covered with sea salt. And there's videos on YouTube. I usually put them on all my postings. Wonderful pictures of these guys with, you know, fixing the soils with biochar. And in fact, Lorraine Green, a woman at the conference, has made the first contract with Superstone Clean Biochar to get their 280 machine, their larger machine, that's a dedicated it has a Stirling engine for power generation and can eat anything. It's a nice size. I don't have price numbers, but I've talked to George at Superstone Clean, and they've been in business for years now. It's one of the longest in the market pyrolysis machines I know of. But this work with Fukushima, and there's also a two-edged sword. In the soils that have just a little bit of cadmium and radioactivity, you can use biochar like DuPont's using it to bind it out of the food chain. In soils that are heavily contaminated, you can do phytoremediation, like some people have experimented at Chernobyl, where you grow sunflowers that are known to draw up daughters of uranium, and then you pyrolysize those, densify them into charcoal, vitrify them, and throw them in a cave. And through biology, through the exponential growth of biologic systems, which I often use to describe what Cool Planet is going to be doing if everything goes right, is we got to get the life on our side, the soil life, the surface life, the exponential growth of biological systems. When you have these guys on your side, as David Yarrow says, when you get the microbes doing the heavy lifting, we have more than a chance. We have the whole living biosphere as our allies. And it's just getting the balance right. It's just feeding them what they need, helping them with char, helping them with ruminant grazing, and doing this on a worldwide scale. It's going to be Eden again. And this is why I got into this business of soil carbon, because literally I've sold this thing I just gave you to Saudi sheikhs and at Dubai, basically saying you can make the Levant Eden